Hi, today we're discussing problem number 1095, find in mountain array. The problem says we are given a mountain array. We are also given the target. We need to find this target in the mountain array and return the index of it. An array will be considered as mountain array if it follows the given two conditions. The conditions are first condition is the length of the array should be greater than or equal to 3. And the second condition is there should be some index where the elements or the numbers which are present before that should be in the ascending order, and after that element the elements should be in the descending order. Let's take one example, this 1 2 3 and 2 1. So if you see, if you take this index 3, the elements before 3 including 3, these are in ascending order, and from 3 these are in descending order. And also this array length is greater than or equal to 3. This is 5, this is 5, so it follows the two conditions, so this is known as the mountain array. uh, we are also given that we don't have direct access to a mountain array, to the direct array. We have given this class of mountain array, mountain arrays object, and inside this mountain array there is the actual array. So we cannot access this directly. We can access it via getters only. So there is only one public getter, as you can see here. So we can, so this will return the value at that particular index. So using this only, we need to search for the index. So it is also given that we can only call this get method 100 times. So we cannot call this more than 100 times. So this is one constraint that we need to follow. So yeah, so the brute force solution for this will be, we can iterate over the array. So we have this length. So we will iterate from 0 to this length minus 1, length being n minus 1. We will iterate and we will try to get the value using get of this index. And then if we if it is equal to target, then we will return I. So this will be brute force solution. But if you follow this, the problem will be, see, we have 10 power 4 length. So we need to, in worst case, we need to do 10 power 4, which is 10,000 times. We need to call get index, which is greater than 100. So we are only allowed to call this 100 times. So this solution is not optimal. Let's try to see if we can optimize this. Let me erase. Yeah. So let's take one example and understand what is happening here. So let's take this example, 1 2 3 4 5 3 and 1. So here, if you observe, so this array is sorted and this array is sorted in the reverse order. Till here. Yeah, this array is sorted till 5, and this from 5 to 5 3 1, this is sorted in reverse order. So now if you see, can we apply binary search on this array to find if this particular target is present here or not? And also we can apply binary search on this array to find if the target is present or not. So we will try to divide this array into two parts, and let's try to find the target in first array, I mean first increasing order array, and then let's try to find this in the second array. So then the complexity will be order of log n instead of n. So but for this to happen, we need to find this point where we have the peak. So why do we call this a peak? If you draw this in the number line, if you see, first one is at 1. So 1, 2, 3, 4, 5, 2, 3, 4, 5. So let's take these as the indices, right? So first point is at 1, second one is at 2, third one is at 3, next is at 5, next is at 3, next is at 1. So if you see, this is forming a mountain structure. Yeah. So this is forming a mountain structure. That's why this is called as mountain array. So we need to find this peak. We need to find this peak value, and then we can apply binary search separately on this array and on this array to find our target. If we, since we need to return the minimum index, if we find the target in this array, we can return. If not, we'll try to find it here. If we are unable to find it here also, then we will return -1 as they mentioned. So if we find somehow this peak index, then yeah, we are good to go. So let's see. So if you observe the elements before this peak index, right, these are less than the peak index, and the element next to the peak index is greater than the peak index, right? So yeah, using this, we can find the peak index. We will search in the array where there is the peak. So for this also, we will use binary search. So let's take this example. Let me clear this first. So now we know that if an element has to be a peak index, then it has to follow this condition that the elements that are present on the left side should be less than the peak value. If it is a peak, the elements present in the left side should be less, and also the elements in the right side also will be on the will be lesser than the peak value. So let's take one way to solve this is, let's take the same example, 4, 5, 3, 1. So so like how we take in binary search, let's take low value as 0 and high value as length -1, which is 1, 2, 3, 4, 5, 6, 7, 7 -1, 6. So mid will be equal to now 6 plus 0 by 2, which is 3. So what is at 3? So 0, 1, 2, 3. So we have 4 at third index. So if you see left side of 4, it is 3, and right side it is 5, right? So now if you observe, left side is less than the value at m, and the right side is greater than the value which is at middle. So this is in the ascending order. It is not in the I mean, this is not the peak. Like for I mean, for an element to be at peak, it has to be the greater element in the array, and I mean, the both left side and right side elements should be less than this element. So but since here the left side element is lesser than the element and right side element is greater than the element, this 4 is not the peak. Also now where do we move? Since this is the left side element is less and the right side element is also less, this is in the ascending order. But for peak, so since this is in the ascending order, and we know that in mountain array, first we have ascending order and then peak and then descending order. Since this 4 is in this range, we no need to search in this range again now. So we can search in the right range. So this 4 is not the peak, and I mean, we are sure that it will not be present in the left side because this 4 is in the ascending order. So we will search it in the right side. So we can eliminate this left half array, and we can increase this low to 4, and high will remain same. Right now, mid will be equal to 4 plus 6, 10, 10 by 2, 5, 0, 1, 2, 3, 4, 5. 5 will be this 3, 5, and now number is 3. So this 3 is, I mean, left side element is greater than the 3, and right side element is less than 3, which is 1. So now if you see, I mean, it is not again following the condition to be at its peak. So what do we do now? Since, I mean, this left side element is less than, I mean, left side element is greater than the element at mid. So it means this array is in mid element, this array is in descending order, so it is right side of the peak, so we need to move left side. So if we want to move left side, then we need to update this m equal to 5. So yeah, now let me clear this. Now 1 2 3 4 5 3 and 1. Okay, so now we have eliminated this already, and they have eliminated till here, and we have eliminated this. Now low will be equal to this index, fourth index, and high will be equal to, I mean, here also, since we eliminated this, it will be 4. Now I will calculate the mid. 4 plus 4 by 2, which is 4. So this is at 4, the element is 5, which is greater than the element at left side, and also which is greater than the element at left right side. So we found our peak. So the peak is at index 4. So this way we can find the peak in the array. So we can divide this into 2 arrays. I mean, one is this array and the next one is this array. And we can apply binary search on this because these 2 arrays are sorted. Now, to find this peak, we are calling get index. How many times we are calling this? 3 times. I mean, for each iteration, we need to get the left value, we need to get the right value, and we need to get the middle value. So, I mean, can we optimize it further? So let's see if we can optimize this further. So if you observe this carefully, right, let's take this example. Let's take this array. So 1, 2, 3, 4, 5, and 3, 1. So if you observe this carefully, so for all the left side elements, the next value is greater than. So if you take this element, this next value is 3, which is greater than the current element. And this side, if you take any value, the next value will be less than that. So for peak, right, the next value will be greater than that. I mean for peak, sorry, for peak, here peak is 5. The next value will be what do we say? For peak, the next value will be less than the earlier value. So let's say, let's take an example and see, without 2 comparisons also we can move right and left. So 1 2 3 4 5 and 1. So here if you see, uh, mid value is equal to uh, low plus high, 0 0 plus 7 7 by 2, which is 3. So index 3. So at this point, if you take the next value which is 5, 4 is less than 5. So I mean at this point only we know that, I mean, this is in the increasing order, because the next value is greater than the current value. So only in the ascending order it is possible the next value is uh, greater than the mid value. Similarly in the so we don't need to check the left value, so we can check with the right value, so that if the right value is greater than the mid value, then we know that this is in the ascending order, right? Similarly for the descending order, if the right value is less than the current value, if mid is pointing here, if the right value, which is 1, if it is less than the current, when the value which is at mid, then we know that this is in the increasing order. So now the answer will be in the left side. So here we are not checking both left and right side. So by just checking the right side, I mean, we are able to identify if this particular array is in the increasing order, if that particular element is in the increasing order, or in the left, in the decreasing order. So yeah, I mean, just take 1 or 2 examples yourself, and if you don't understand it, so you'll be able to, yeah, get it. So yeah, I mean, basic intuition is just that in the increasing order, the next value will be always greater than the left value. So if we are in the increasing order, then we are not at peak. Similarly, if we are in the decreasing order, we are not at peak. So ultimately, we can move, if we are if we are in increasing order, we can move pointer to the right side. If we are in decreasing order, we can move pointer to the left side, so that we can reach the peak. So now we know how to get the peak. So after getting that peak value, we will search in the left side, and we will if we are able to get the index, yeah, well and good, we will return that index. If we are unable to get it, we will search in the right side. So let me quickly write pseudocode for this. uh, so first step will be mm, find the peak in using binary search. So this mean peak equal to something like this, and then second step will be search for target. Search for target in left array. I mean from 0 to peak index. If found, return that. If not, then search for the target in the right side. I mean, which is from peak index to the mount. Yeah, I mean length of the array, or maybe length minus 1. So we found, return that index. If not, return minus 1 as given here in the question. So let's quickly try to implement um, okay. So let's first calculate the n value, and let's get the length of the array. So for getting length, they have given this length a length function. So using that mountain array dot length, we have got the length. First step is finding the peak. So if you observe, right, the peak will be so the length of the array is minimum 3 as they have given. So in order an array to be peak, right, the peak should not be at this place, because we need at least one index where there is increasing order and there is decreasing order. So we cannot have something like this, so where the peak is at this place. No, sorry, we cannot have something like this, right, where peak is at 3 and there are no elements left side to it. So it should be at the middle, or at least we can have something like this: 1 3 2 1 and 0, so that the peak is there, something like this, right? So we need peak. So if we should have peak, then it should be at least from one index, or the maximum index where the peak can be found is length of the array n. This is the n minus 1 index. So maximum place where peak can be found is n minus 2. So I mean, it's the peak. I mean, basically the peak will not be at the extreme ends because of this condition. We need at least one index. I mean, yeah. So for peak, the low will be for this. I mean, for doing this binary search, the low will be, I mean, peak will be at left side of at least at the 1th index, and the high will be n minus 2, right? So now we will try to find the earth index. While low is less than or equal to, or while low is not equal to high, uh, so we'll get this. So int mid equal to low plus high minus low by 2, and if mountain array dot get of mid. So if this middle element is less than mountain element dot get of mid plus 1. If this is the case, then we need to move right side. As this is in the increasing order, then we need to move to the right side. Low equal to mid plus 1. Else, if it is not, if it is in the decreasing order, even if it is even at the peak also, right? Uh, if you observe, right, 1 2 3 2 1. So at peak also, the next element is lesser. So at peak also, the elements are in descending order. So if we found, if this is not the case, if the next element is not greater than the element, then we can just simply I mean, we don't need to decrease the height, because even middle element can be at the I mean, if the when middle element is in the decreasing order compared to the right side. So I'll do, we will just write high value as mid. So yeah, now peak index will be at so and research. Now we found the peak. Now we found the peak. So we need to I mean, this low and high, I mean, if you get confused with this, since we are doing this I mean, till this low is not equal to high, we will only come out of this when low is equal to high. So we can assign this to high also. I mean, anything, I mean, we are at the peak index now. I mean, we have, we have decreased all the lengths, I mean, from left side and right side, and we are at the peak index now. So peak will be, I mean, either low or high. I mean, both are same. If you are confusing why it's only low and not high. So now we need to search in the 0th index to the peak. So now again, we are using the same law to do first binary search. Low will be equal to 0. I mean, the index can be at the 0th position, and high will be equal to peak that we got. Now again, we will do binary search while low is not equal to high. Or we can do while low is less than or equal to high also. It's anything is fine. Int mid equal to low plus high minus low by 2, and if this mountain array dot get of mid, if it is less than target, then we need to law will be equal to mid plus and if else, if then I will be equal to mid. I mean, we can also check if array equal to target, then we can return this mid from here. But here we are calling so many mids, so we can just assign this to current, int current equal to something like this. And if current equal to mid, then this. If not, yeah. So yeah, it did not found. If we did not find, then we will search it in the right index, where low will be equal to peak. I mean, we have already searched in the peak, so I'm taking from peak plus 1. We can take from peak also, but the peak is covered in this array. If it is at the peak, we would have already returned it. And then high will be equal to n minus 1. So CM will apply binary search. It's not equal to high. Then int mid equal to and then int current element equal to same. And if current equal to target, then we will return that mid. And is it is equal to target, we will return that if current is greater than the target, then if current is greater than the target, since we are searching in the descending order, so we need to increase this low equal to mid plus 1. else um, will change height to get a mid. And when we break, we will check if mountain array dot get if it is at low, because low and higher equal to the target, then we will return that low. If we are not able to find it in both the arrays, we'll return -1. We can also do this here before calculate the second one, just to handle the edge cases. And let's see. Okay. I'm also submitting this for the first time today. Okay. Let me submit. Yeah, it got accepted and paid 100% of the users. So yeah, that's it for this question. Thank you for watching.